Good morning students. Welcome to today's chemistry class. So I hope that all of you have taken the answer key of the objective type questions which I have told you to take down from the school website. Okay. So we have started the next chapter, that is element, compounds and mixture. And in that we have discussed about elements. Then we have discussed about various type of symbols, how they are formed. Then we have talked about compounds. Then we were talking about formula also, that how the formula is formed. Then we have talked about characteristics of compound, and in that we have discussed the first point, that the chemical compounds cannot be split into its constituent elements by any physical means. They can only be split by chemical means. Okay, so let's move to the next point, that is the properties of the compound is totally different from its constituent elements. We have already discussed about the first point. Okay, and in that we have also discussed that what are the various other methods by which hydrogen gas can be obtained. So till there I have discussed already. Now we are going to discuss the second point. So second point says that the property of the compound is totally different from its constituent element. So let's take an example of water. Okay, so what we see, water H2O. Okay, so it is in the liquid state, but its constituent elements, that is hydrogen and oxygen, both are in the gaseous state. Okay, so the property of the constituent element, that is hydrogen and oxygen, is totally different from the compound what it's formed, that is H2O. Okay, similarly we can take example of carbon dioxide also. Okay, so the property of the carbon dioxide is totally different from its constituent element, that is carbon and oxygen. Similarly we can take example of mercurous iodide. Okay, mercurous iodide. Okay, so in this mercurous iodide you can see its form of mercury and iodine. What are the two constituent elements? Mercury and iodine. So mercury, this mercurous iodide is yellow color solid, but what about mercury? It is silvery white liquid, silvery white liquid. And what about iodine? It is black violet solid. Okay, what is the color of the iodine? Black violet solid. Okay, now what about copper sulfate? CuSO4, copper sulfate pentahydrate. Okay, so this is the name of the compound, copper 2 sulfate pentahydrate. So this compound is blue color. Okay, it is blue color solid, but what are the constituent element? It is form of copper, sulfur, oxygen and hydrogen. So these are the constituent elements of copper 2 sulfate pentahydrate. This as a whole, this compound as a whole is blue color solid. But what about copper? Copper is red color metal. Okay, sulfur is in yellow color, and oxygen and hydrogen is what? Colorless gas. Okay, once more I want to repeat that copper 2 sulfate pentahydrate is blue color solid, and its constituent element, that is copper, is red in color, red color metal, sulfur is yellow color solid, and oxygen and hydrogen is colorless gas. So what we can conclude from all these examples, that the constituent elements of the compound is totally different from the original compound. Okay, so this was the second property. Now let's move towards third property, what it says. So third property says that elements combine in a fixed proportion of atom. Elements combine. Now this point is very important. Elements combine in a fixed proportion, of atom to form a compound. Okay, elements combine in a fixed proportion of atoms to form a compound. So what is the meaning of this sentence? Let's understand it with the help of one example. Let's take the basic example of H2O. Okay, so in the H2O molecule, how many hydrogen atom is present? 2 hydrogen atom. Then what about oxygen? How many oxygen atom is present? 1. So what is the atomic ratio here? 2:1. Means hydrogen is present what amount? 2, and oxygen is present in 1 amount. So atomic ratio means the ratio of the atoms is what? 2:1. Then what about carbon dioxide? Here what you can see? How many atoms of carbon? 1. And how many atoms of oxygen? 2. So atomic ratio of carbon and oxygen in carbon dioxide is 1:2. So similarly, you can take some other examples. You take example of sulfuric acid, H2SO4. So here, what are the 3 atoms or 3 elements which you can see? Hydrogen, sulfur and oxygen. So there are 3 elements. So now what will the atomic ratio of these elements? How many hydrogen atom? 2. How many sulfur atom? 1. How many oxygen atom? 4. So the atomic ratio of hydrogen, sulfur and oxygen in the molecule of sulfuric acid is 2:1:4. Okay, so elements combine in a fixed proportion of atom. Means if one molecule of hydrogen is having this atomic ratio, then every molecule of the water will be having the same atomic ratio. Similarly, if the one molecule of carbon dioxide is having the atomic ratio of 1:2, then every molecule of carbon dioxide will be having the same atomic ratio. Okay, so I think that this concept is clear. Okay, now we are moving towards, okay, so I think that this concept is clear. Here what we mean is that 2 atoms of hydrogen combine with 1 atom of oxygen, and because of this atomic ratio is 2:1. Okay, here in carbon dioxide 1 atom of carbon combines with 2 atoms of oxygen. So that is why the atomic ratio is 1:2. Similarly, you can take some other examples also and can understand this. Okay, let's move towards the 4th and last characteristics of a compound. Okay, now the 4th characteristic states that the compounds contain the constituent element. The compounds contains the constituent elements in fixed proportion of mass. Okay, so the 4th characteristic states that the compounds contains the constituent elements in a fixed proportion of mass. So let us understand the meaning of this sentence with the help of water molecule. Okay, so we are taking the basic example of water molecule. So already you have seen that how many atoms of hydrogen is present in water molecule? 2, and 1 atom of oxygen is present in the 1 molecule of water molecule. Okay, so here in this we are going to talk about the atomic mass ratio. Okay, when we will take out the atomic mass ratio, then we will understand the proportion of fixed proportion of mass. So when you will reach a higher class, you will learn that the atomic mass of hydrogen is 1 AMU, atomic mass unit, and atomic mass of oxygen is 16 AMU. Okay, so I am telling you in advance, these things you will be learning in the higher class. So just for your information, I am telling you that atomic mass of hydrogen is, one atom of hydrogen is 1 AMU and one atom of oxygen is 16 AMU. And what about water molecule? How many atoms are present? How many atoms of hydrogen is present in one molecule of water? 2. So total atomic mass will be what? 2 into 1, that is 2, and 2 AMU. What about oxygen? It will be 16 only, because total number of oxygen present in the water molecule is 1. Okay, so hydrogen H2 will be total what, and oxygen will be 16. So when you will take out the ratio of 2 atoms of hydrogen and 1 atom of oxygen, then what it will be? 2:16 means 1:8. Okay, so the atomic mass ratio of hydrogen and oxygen in one molecule of water is 1:8. So you can say that by mass, water contain 1 part of hydrogen and 8 part of oxygen. Okay, so by this what you can conclude, that by mass water contains 1 part of hydrogen and 8 parts of oxygen. Okay, so now every 9 grams of the water will contain how many hydrogen and how many grams of hydrogen and how many grams of oxygen? The answer will be what? 9 grams. From where this 9 grams came? When you will add this, what it will be? 1 plus 8 will be what? 9. Okay, so now why I am doing so? I am asking that every 9 grams means what? Every 9 grams of water will contains how many grams of hydrogen and oxygen? So the answer will be 1 gram and 8 gram. So when you will add 1 gram and 8 grams, so answer will be what? 9 gram. And from where I have came to the conclusion? From the law of conservation of mass. Okay, from the law of conservation of mass, what we can say? The mass of the reactant will always be equal to mass of the product. Okay, so this was all about. So in order to understand it better, let's take example of some other compounds. So let's take example of carbon dioxide. Carbon dioxide. So here also what conclusion is there, that by mass carbon dioxide contains 3 parts of carbon, and 8 parts of oxygen. What it says that that by mass carbon dioxide contains 3 parts of carbon and 8 parts of oxygen. So from where this 3:8 atomic ratio came? Again it came from the atomic mass of each element present. So the carbon atomic mass is what? 12 AMU, and oxygen atomic mass already we have learned is 16 AMU. Okay, so this was the atomic mass of carbon and oxygen atoms respectively. So when we will take out the ratio of the atomic mass of number of carbon and number of oxygen present, then how it will be taken out? For the carbon, only 1 atom of carbon is there, so it will be 12 AMU. What about oxygen? How many atoms of oxygen present? 2. So it will be 16 into 2, that is 32 AMU. And when you will take out ratio of carbon and oxygen, what it will be? 12:32. Reduce it, what answer you will get? Okay, 4 3s are 12 and then 4 8s are 32. So ratio will be what? 3:8. So the atomic mass ratio of carbon and oxygen in carbon dioxide molecule is 3:8. So what conclusion we can say? That if 3 grams for forming how many grams? 8, 9, 10, 11. For forming 11 grams of carbon dioxide, we need what? 3 grams of carbon and 8 grams of oxygen. Okay. So for forming what? Thus for every 11 grams of carbon dioxide will contain 3 grams of carbon and 8 grams of oxygen. Okay. Like this we come to the conclusion of atomic mass ratio. I think that this concept is clear. Okay, though it is not required at your level, but try to understand that what this sentence talks about. Okay, so the compound contains the constituent element in fixed proportion of mass. Okay, so their mass do not change every time. Their mass will be always constant. Okay, it will be constant, though their number of molecules can vary. But the atomic mass ratio of the elements in every molecule of the particular compound will always be same. It will not vary. Okay. So I think that this concept is clear. Okay. Now we are moving towards the next topic, that is mixture. Okay. So now this mixture topic, I think that you all have read in your previous class also. Okay. And what are the various examples of the mixture also, I think you have read already. So let's do the quick revision first. Okay. Mixtures. Now, earlier we have learned that elements and compounds are pure substance. Pure substance means what? These substances cannot be split into its constituent elements by any physical means. They can only be split by chemical means. And what definition we have read about the pure substance? Pure substances are those substances which cannot be what? Which cannot be split by any physical means. So elements are and compounds are under the category of pure substance because they cannot be split into its constituent elements by any physical means. But though they are pure substances, they are never found in a pure state. Okay, so you just look around you, whatever elements you can see or compounds you can see around you, they are never found in the pure state. They either mix with themselves, elements are mixed among themselves, or they mix with any other compound. Okay, and because of this, mixture comes into existence. From where this mixture came into existence? It is due to the mixing of various types of elements together, or the mixing of various types of elements with the various types of compounds. So because of this, mixture came into existence. So let's see various types of mixture. Okay, what about air? The air which we see feel around us contains various types of elements such as oxygen, nitrogen. Okay, oxygen, nitrogen, and then various types of noble gases are also there. Okay, so these are the various types of elements present. What about the various type of compound? Water molecule is there. Okay, carbon dioxide is there. So these are the various type of compounds present. So in air, you can see that elements are mixed together with various types of compounds. So hence, air is what? A mixture. Then what about your natural water? Natural water which we get is also a mixture of various type of minerals and salts, or various type of metal such as chloride, sulfates and hydrocarbonates. So these are the various type of salts present, and as well as their various types of minerals are also present, and some of the dissolved gases are also there in the natural water. So various things are mixed together, and hence we can say that natural water is also a mixture. Similarly, seawater. Okay, seawater is also a mixture because from where you get salt and all, you get from the seawater. So hence you can say that it is also a mixture. Okay. Now, so by this what we can say, that the substance are what? Impure. They are not pure, and hence they are all a mixture. They are all called as mixture. The different pure substance of which a mixture is made of is known as components of a mixture. So I have talked about air. So it's made of hydrogen gas, carbon dioxide gas, oxygen gas, noble gases, water. Water molecules are also there, or you can say water vapor is also there. Hence all these are what? Components of the particular mixture, that is air. Okay, so likewise whatever pure substance, because hydrogen, oxygen, carbon dioxide, all are what? Pure substance only, and they are mixed together to form a mixture. Okay, and all these are known as what? Components of a mixture. Now these components can be separated by what? By physical method, and hence you can say that mixture is a impure substance. Mixture is what? Impure substance, because it can be split into its constituent elements by physical means. Okay, element and compounds are pure substances, but mixture is not a pure substance because it can split into its constituent elements by physical means. So let's see what the definition says about mixture. So a mixture is a substance. A mixture is a substance which can be split into its constituent elements by a physical means. Such as what? Sublimation, filtration, distillation. So these are all a physical means by which the components, or you can say the constituent of the mixture, can be separated. Okay, so once more I will repeat it. A mixture is a substance which can be split into its constituent elements by physical means, or you can say constituent substance, two or more pure substance by physical means. A mixture is a substance which can be split into its constituent elements by physical means. Now in any mixture, now we have talked about air. So it is mixture of various type of gases. All these gases are present together, but they do not chemically react among themselves, or you can say that there is no such chemical bond between them. They exist independently. So in mixture, substance can stay together without any kind of chemical reaction, or you can say that they are not chemically bonded. In the mixture, the substance, various type of pure substance, you can say in mixture, various type of pure substances can stay together without any chemical bondage. Okay, I think the definition of the mixture is clear. Now let's take some examples of mixture. I think this definition is clear. Now there are various type of mixture around us. So some of the mixtures are naturally found and some of the mixtures are man-made. Okay, there are various types of mixture. So we are now taking examples of mixture. Examples of mixture. Okay, so what I have told right now, there are various type of mixtures around us. So some of the mixture is naturally found and some of the mixtures are man-made. So let's talk about some of the naturally found mixture. So just now I have talked about air. So it is naturally found mixture of various type of gases such as oxygen, nitrogen, carbon dioxide, water vapor, noble gases, etc. Okay, and now these components, that is gaseous components, can be separated by physical means, and hence you can say that air is a mixture. What about natural water? Just now I have told you it is also mixture of dissolved gases and various types of minerals. Then soil, which you see, soil is also a mixture of various types of minerals, water. Okay, so this is also naturally found mixture. What about various type of foodstuffs? Foodstuffs which we take. Okay, foodstuffs such as rice, pulses, vegetables, meat, milk, butter, all these are the foodstuffs which we take is also what? Mixture, because they are mixture of protein, vitamins, then fats, then salt, water. So these are the various components which are present in the foodstuffs, and hence you can say that the various type of foodstuffs are also mixture. Okay, the components are staying together but they are not chemically bonded, and because of this you can get vitamins also, you can get protein also. If they are chemically bonded, that you will not able to gain them. Because they are not chemically bonded, you can able to get the vitamins, proteins and useful things from these type of food stuffs. Okay, now these are the various naturally found mixture. Let's talk about some of the man-made mixture. Now there are various type of man-made mixtures also. Okay, and these mixtures are of very much use. Okay, man has made various type of mixture and these type of mixtures are very much of use. So let's talk about first is medicine. Medicines. Now in medicines active ingredients are there. Okay, in medicines some amount of active ingredient is mixed with some other substances. Okay, active ingredient is there, but that active ingredient is very much in very much little amount. Okay, you can say some milligrams of active ingredient is used in any medicines, but there are other substances also mixed with the active ingredients. Okay, so by this you can say that it is also a mixture, because active ingredients are mixed with some amount of other substances also. Now why this now I will tell you the reason why the other substances are also mixed with active ingredients. Okay, so these substances provide two benefits. First of all, the active ingredient which is added is shows very much harshnesses. Okay, it is very much harsh. But if you will add some amount of other substance also along with the active ingredient, then the harsh effect of the active ingredient can be reduced and it will not be that much harsh. Otherwise it can be very much harsh. Okay, and the second use is that it increases the bulk, because I have told you right now that active ingredient is added in very much little amount, in some milligrams. So it will be very much difficult to dispense, or you can say that it will be very much difficult to store it or to give to someone. Okay, if it will very much in very much small amount, then it will be very much difficult to store it or to give to someone. So that is why in order to add bulk to it, some amount of other substances are also added. Okay, so now the question can be asked that why some other substances are also added to the medicines along with the active ingredient. Then you will give the two reasons. First reason is that in order to reduce the harshness of the active ingredient, and the second is thing to increase the bulk, and hence it becomes easy to dispense the medicine. Okay, I think that medicine part is clear. Okay, now the next is alloy. Now this alloy part is very much important. Okay, now alloy is also a man-made mixture. So let's talk about what this alloy is. So alloy is a mixture of two or different type of substances in which at least one is metal, or you can say that an alloy is a uniform mixture of two or more elements in which one of the element is metal. Okay, so I am writing here alloy. An alloy is a uniform mixture of two or more elements in which one of the element is metal. Okay, so it's not necessary that only one element should be metal. The whole alloy can also be formed with the only metallic elements. But if some non-metals are added, then it is necessary that one of the element should be a metal. Okay, so this is the condition for forming any alloy. Okay, so generally the alloy of metals are formed, and in the formation of alloy of metals, some non-metals can also be added. That is why it is mentioned here that one of the element is metal. So an alloy is a uniform mixture of two or more elements in which one of the element is a metal. Okay, so you can say that it is a homogeneous mixture because I have written here uniform mixture. So this is the definition of alloy. Now, why these alloys are formed? Why there is a need of the formation of alloys? Okay, so there are various type of alloy which is found around us. Okay, so very first example is of stainless steel. Now these alloys which I am talking about is very important, okay, from the examination point of view also. So please pay attention to it. Okay, so first alloy is stainless steel. Now stainless steel is very much common around us, and I hope that all of you have seen stainless steel. So stainless steel is basically used for making utensils. Okay, so what are the various elements present in this alloy? Stainless steel is an alloy, so it is alloy of iron. It is basically the alloy of iron in which some other elements are also mixed. Okay, so in this it is iron, chromium, nickel. So this is the symbol of the elements: iron, chromium and nickel. What are the three elements present in the alloy of this iron, stainless steel? Iron, chromium and nickel. So there is simple steel also. Simple steel, okay, so this is stainless steel, and simple steel is there, which is also an alloy. So it is alloy of iron, carbon and manganese. Okay, so it is the alloy of iron, carbon and manganese. So I have written in symbolic form. Okay, so why there is need of making this stainless steel or steel of this is alloy of iron? So why there is a need? As you already know, the simple iron get rusted very easily. So in order to avoid this property of rusting, alloy of iron, stainless steel and steel is formed. Okay, so there is some benefit also when we form alloy, because the original metal do not have that benefit. So in order to add extra benefit, we form alloy. Okay, let's talk about some other alloys also. Brass. So all of you have heard about this. I think that all of you have heard about this alloy, brass and bronze. Brass is there and bronze is there. So these are the alloys of copper. So we can ask in the examination, give two example of alloy of copper, then brass and bronze. So what are the elements mixed together to form this alloy of copper, that is brass? Copper is mixed with the zinc. Okay, and here bronze is mixed, copper is mixed with the tin. Okay, Sn. So these are the symbols. Brass is the alloy of copper and bronze is also alloy of copper, and here in the brass copper is mixed with the zinc, and in the bronze copper is mixed with the tin. Okay, so these are the alloys of copper. Now why they are made because they are more useful than the copper. Original metal is what? Copper. These alloys were made by because they show more useful properties than the copper. Okay. So basically the aim of formation of alloy is to gain the benefit, okay, to improve the quality of the metal. Generally the original material do not have that property, so in order to improve the property, alloy is made. So this is what? Zinc, and this is tin. Okay, I'm writing here. Okay, I think that this is clear. Now let's talk about gold. The gold which we get in the market, okay, so you would have heard about the carat and all. Okay, so carat show the purity of the gold. 18 carat, then 16 carat, 22 carat. So these are the carats which we hear in the gold market. So what these carats shows? It shows the purity of the gold. So why the pure gold is not used for making any jewelry? If you will use the pure gold for making jewelry, then it will not be hard. Okay, it will be very much easy to bend. Okay, it will not have the proper shape, and it will be very difficult to give them shape. So in order to give them perfect shape, gold is also mixed with some of the metals. So the gold is mixed with silver, okay, silver and copper. Gold is generally mixed with silver and copper. Okay, why it does? Because in order to give gold jewelry proper shape, or any other articles which we make out of gold, then proper shape can only be given when some amount of silver and copper is added. So it add hardness to the gold. Gold become hard after adding this, and purity of gold also decreases. So it's totally depend upon the amount of silver and copper added to the gold. Okay, the how pure that gold is. Now let's talk about some other example. Okay, this example is not given in your book. So duralumin. Duralumin. Okay, so this is also the alloy of aluminium. Okay, so this is the alloy of aluminium, and in this aluminium is mixed with magnesium and manganese. Okay, so what are the three elements present in the alloy of aluminum? That is duralumin, aluminium, magnesium and manganese. Now the original aluminium is not that much strong, okay, though it is light, but it is not very much strong, and it is also not corrosion resistant. But if we form this alloy duralumin, then the aluminium becomes very much strong also, and as well as it is light. Previously it was light but not strong, but when we form this alloy, then it becomes strong also, and it will be light also, and as well as it is corrosion resistance. So we have got what? Three properties. So what this alloy formation basically done? This alloy formation basically improves the quality of the metal, that is aluminium, and hence whatever airplane or which you see is made of what alloy? It is made of duralumin. So airplane is made of aluminium. Why? Because it is light in weight, and duralumin alloy is used because it is strong also and corrosion resistance. Okay, so this was all about the alloy and its example. I think this alloy is clear. Now let's move towards the next example, that is cement and glass. Okay, next is cement and glass. Okay, so cement and glass are also mixture. Okay, so the cement is mixture of calcium silicate and aluminium silicate. So basically cement and glass are the mixture of silicates of metals. Okay, basically cement and glass is what? Is a mixture of the silicates of metals. So what are the metallic silicates present in cement? In cement, calcium silicate is mixed with aluminium silicate. What about glass? Okay, so in glass, sodium silicate is mixed with the potassium silicate and lead silicate. So in this, sodium silicate is mixed with potassium silicate and lead silicate. Okay, so cement and glass are also mixture. As you can see, the components of the mixture is cement is calcium silicate and aluminum silicate. Glass is the mixture of sodium silicate, potassium silicate and lead silicate. So these are the various examples of the mixture. So I hope that today's topic is clear to you all, and we have talked about various types of examples of mixture. Then we have talked about what are the various characteristics of the compound. Everything is clear. So now next class we are going to study about characteristics of mixture. Okay, till then whatever we have talked today, revise it and try to learn, and please start learning all the question answers also of the previous chapter. Okay, thank you.